Okay, so we're going to talk about taking derivatives right now. And we're going to do a couple of these. I'll show you the rules. Derivatives. So the one that we saw that comes up all the time, if I have the derivative with respect to x of x to the n, that's going to be, the derivative will be n times x to the n minus 1 power. For instance, if you have the derivative of x cubed, you'll pull the 3 down front, and then that's times x to the 3 minus 1, or 3 times x squared. Okay, another one that comes up a lot, if you take the derivative of a constant, we'll just call it k, that's 0. Okay, what you're looking for essentially when you take derivatives is a place, so if you've got a function that looks like this, you're looking for places where the direction of the function changes. So depending on the kind of curve you have, the derivative will show up there. So that's why we take things and set them equal to, take the derivative and set them equal to 0. Something weird is going on. That's okay. Alright, so what if I have, say, a constant times x? I take the derivative. You always just bring the constant along. And then you have, in this case, it would be 1 times x to the 1 minus 1 power, or k times x to the 0. But anything to the 0 power is just 1. So you have just plain k. Oh, hit the wrong thing. Alright, let's get a new slide here. So what if I have something like y is equal to e to the x. Alright, and I want to get dy dx, another way of writing the derivative. But e is an unusual function. You always just repeat the original term and then multiply it by the derivative of the power. So in this case, the power is just plain x. So that's just like taking the derivative of x. So that's going to be 1 times e to the 1 minus x to the 1 minus 1 power, or e times x to the 0, which is e to the x. Okay? Yeah, so e always repeats itself, and then you take the derivative of the power. This comes up a lot in probability and statistics. So suppose I have e to the x squared. I want to take the, sorry, let me get that out of there. The derivative of e to the x squared. Then that's going to be e to the x squared times the derivative of the power. So that's going to be 2 times x to the 2 minus 1 power, or e to the x squared 2x. And you normally put the 2, then the x, then the e to the x squared. Okay? Something that comes up a lot. Let's see, you've got these, you've got those. Oh, let's do one more. Suppose I had 4 times e to the 3x, and I want to take the derivative. I don't know why I keep writing equals here. I want to get the derivative of that. So the constant stays out front, times e to the 3x. Then you take the derivative of 3x, but that's just going to be 3 times x to the 1 minus 1 power. So I'm going to end up with 12 e to the 3x. Okay? So that's pretty straightforward. So the next thing, and I'm giving you a very fast tour of differential calculus. You may run into this if you have, let's go back to that 2x e to the 2x, or excuse me, e to the x squared power. And I want to get the derivative of that. You actually have to use something called the product rule, because this is the product of terms with two terms with variables in them. So in that case, you're going to take well, let me write a formula. If you have y is equal to f of x times g of x, you can write the derivative as f of x times g prime of x. That's the derivative of g, plus g of x times f prime of x. Okay? So in this problem here, let's let f of x equal to 2x, g of x is equal to e to the x squared. So f prime of x, that's just the derivative, is just going to be 2. That's the derivative of 2x. G prime of x is equal to, and we've actually done that before, it's going to be 2x times e to the x squared. Okay, so in order to get the derivative of the whole thing, you're going to have f of x, so there's your 2x, times g prime of x, so that's, times 2x e to the x squared plus g of x, which is e to the x squared, times f prime of x, which is 2. So let's put this all together. We have 4x squared e to the x squared plus 2 e to the x squared. It's an equals, and if you're feeling particularly fancy, you may want to write that as 2 e to the x squared times 2x plus 1. Okay? All right. So let's take a quick look at integration. Again, I'm just giving you a smattering of this. So if I have the integral of k dx, the integral of a constant, that's just going to be kx. And at the moment we're doing what's called indefinite integrals. There are no limits on the tops and bottoms of the integral sign, so you write it as this. When we're actually doing stuff, we will be doing what's called definite integration, but this just gives you an idea of how to start. Okay, if you have the integral of x to the n dx, that's equal to x to the n plus 1 over n plus 1 plus c. If you have the integral of k x and x to the n dx, what you do is pull the constant on the outside and then have the integral of x to the n dx, but that's just going to be k times x to the n plus 1 over n plus 1. All right, let's do a couple of quick examples. So if I have the integral of 4 dx, that's just going to be 4x plus c. Oops, forgot my plus c over here. Okay? If I have the integral of x to the 4th dx, x to the 4th dx, that's going to be x to the 4 plus 1 over 4 plus 1 plus c, or x to the 5th over 5 plus c. Let's get a new slide. And if we have something like 3x squared dx, then I'm going to push the 3 on the outside, and I'll have the integral of x squared dx, and that's going to be 3 times x to the 2 plus 1 over 2 plus 1, and that's going to be 3x cubed over 3, but my 3's cancel, so I'm left with x cubed plus c. Okay, now let's take a look, and again, this is something that's going to come up a lot. If I have the integral of e to the x dx, that's just itself. Since the derivative is the same, the integral is the same, so that's just going to be e to the x plus c. But it's hardly ever that simple. If I have the integral of e to the minus 4x dx, then I have to think about how, when I take the derivative, how it works, how you're going to repeat the e to the minus 4x and then take the derivative of the power. So I'm essentially doing that in reverse. So I'm going to think about this as this is the final work of taking a derivative, and when you do the integral, you're undoing that. So if this is the final product, I know I have to have a minus 4 somewhere. So I'm going to write this as, in order to make it work out, I need to think about that power here. So this is going to be minus 1/4 e to the minus 4x plus c. So how do I know? Well, you can always get your answer and take the derivative, and that if it comes out to what was originally in the integral sign, then you know you've done it right. So for instance, if I take the derivative with respect to x of minus 1/4 e to the minus 4x, then the the constant sits out in front. I have e to the minus 4x, and then I take the derivative of this, but that's just going to be minus 4 times minus 4. The minus 1/4 times the minus 4 cancel, and that brings me back to e to the minus 4x, which is what I wanted. Okay? All right. Anything? There are actually tables of integrals and derivatives, and I'm going to send you some. And one of the best things that you could do when you're working is look at those tables. If you see something that looks familiar, use that, and it should help. For instance, let me just grab something here. which keeps creeping away. So if I have, this is one out of the table that I'm going to send you. If I have the integral of, whoops, where's my, there it is, okay. If I have the integral of e to the ax dx, that's just going to be 1 over a, 1 over a e to the ax plus c. Okay? So all you do, like in that problem that we just did a minute ago, I had e to the minus 4x dx. I just plug that in. I know that the a, it's the number sitting next to the x, is 1/4. Or excuse me, the number sitting next to the a is minus 4. So I just plug minus 4 in there. E to the minus 4x plus c, which is exactly what we got. Okay? Another one that comes up a lot is x times e to the ax dx. And the integral formula for that is e to the ax over a squared times the quantity a minus 1 plus c. Okay? And you're going to see that we use that in your homework. Sorry, that should be ax. My fault. There you go. Ax minus 1. That comes up in your homework, and you'll see that later today. Okay? Good.